Let's look at an example of a simple molecule. This molecule on the left has a carbon bonded to fluorine, chlorine, bromine, and a hydrogen. The molecule on the right also has the same bonds. Are these two molecules different? One way to think about this is to try to superimpose these two molecules on each other. Superimpose means literally place or lay one thing over the other. You will see that this is impossible. No matter how much you rotate one molecule relative to the other, you will see that they are actually different from one another. The orientation of the bonds are different. These molecules are actually mirror images of one another. If you put a mirror between them, you would see the other molecule in the mirror. If you don't believe me, try it. Draw one of these molecules and use the selfie mirror on your cell phone to see the other molecule. Since this carbon atom has 4 different bonds here, you actually cannot superimpose the mirror image of this molecule onto the other. This is actually a very big area of chemistry. These two molecules have the same molecular formula and have very similar chemical bonds, but they actually have different chemical properties. These two molecules are actually isomers, but we call them stereoisomers. Stereoisomers are concerned with how things are positioned in 3 dimensions, not just how their bonds are different. These two molecules that are mirror images that cannot be superimposed, we call them enantiomers. So these molecules are opposites of each other. They cannot be superimposed, they're mirror images, and they're examples of chiral molecules. If we extend this definition to chemistry, there's really 2 concepts going on here. There are chiral molecules, which is where a molecule's mirror image isn't superimposable on itself. Generally, a chiral molecule contains at least one chiral center or chiral atom, which in most often the case is a chiral carbon when we're talking about organic chemistry. Chiral carbons are carbons that have 4 different groups attached to the carbon. In the case where we find 4 non-identical groups bonded to the carbon, we find a chiral carbon. Generally, if we find a chiral carbon, they're usually part of a chiral molecule, but this isn't always the case. Therefore, it is general practice to examine the mirror image of a molecule to determine if it's a chiral molecule or not. The opposite of a chiral molecule is an achiral molecule, an example of when a molecule is superimposable on its mirror image. Let's look at an example. This carbon center is bonded to 2 hydrogens, a chlorine, and a fluorine. Even though it's similar to the last example, we can see that this carbon has only 3 different substituents, with 2 identical hydrogen groups. These simple changes mean that the carbon is no longer chiral, and when we look at the mirror image, it is superimposable on this molecule. Quite often, we draw a dashed line to indicate a mirror. So if the dashed line is a mirror, the atom distances from the mirror stay the same on both sides, and if the atom's coming towards you before, it's still going to be coming towards you in the mirror. You can draw in the atoms first and then bonds if you like, or vice versa. The mirror image of this molecule would look like this. Now, in this situation, is there any way to rotate this molecule to overlay or superimpose the molecules together? If you were to rotate it, you can see that you would get this exact molecule. So this molecule is said to not be chiral, it is said to be achiral. Let's look at another example. Is this molecule chiral or achiral? Firstly, let's look for a chiral center. It looks like there could be a good candidate for a chiral carbon here, or a carbon with 4 different groups bonded to it. We have a carbon that has a chlorine bonded to it, as well as a methyl group and a propyl group. Also, remember, it is bonded to a hydrogen, so this is definitely a chiral carbon. Let's look at the dash and wedge diagram for this molecule. When you take its mirror image, this is what it looks like. If you take the mirror image of either one, you're going to find that no matter how hard you try to rotate it or shift it, it won't be able to superimpose on its mirror image. So because the mirror image is a different stereoisomer, we have a chiral molecule. Now let's look at this last example here. Let's think about whether we have a chiral center here or whether the molecule as a whole is chiral. 3 of these carbons are really just CH2 groups, but the carbons that have fluorines bonded to them are actually chiral centers. They are bonded to a fluorine, a hydrogen, and then 2 different carbon chains. They are immediately bonded to CH2 groups, but if you continue down both of these chains, they're actually different groups, meaning they have 2 chiral centers in this molecule. To determine if this means it is a chiral molecule, I personally like to draw the mirror image to help. So you can actually just draw the mirror images here. But you'll see that they're also the exact same molecule. I could just literally move one molecule right on top of the other and it would be superimposed. They are exactly the same. So even though we have 2 chiral atoms, 2 chiral carbons, the molecule as a whole is not chiral. It is an achiral molecule. I hope this video was able to show you the differences between chiral and achiral molecules. Thank you for watching.